أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Evaluating measurement model construct reliability. In the last session, we discussed about some basic concepts with regards to SCM. We discussed factor loadings, reliability, R-square, beta coefficients, and some other concepts. In this session, we are going to discuss how to assess construct reliability using SmartPLS 4. The first step is indicator reliability. The first step in reflective measurement model assessment, that is your measurement model assessment, we are going to talk about what is reflective, what is formative, but a little later. For now, this is a reflective model because the arrows are pointing towards the indicator. This is a reflective construct as well because the arrows are pointing towards the indicators. But later we are going to discuss what is formative measure. In most cases, your lower order constructs, that is, the construct with its item, are reflective in nature. However, the higher order constructs, let's say if CC had subdimensions, now those subdimensions could either be reflective or formative. Coming back to our topic for now, the first step in reflective measurement model assessment involves examining how much each indicator's variance is explained by its construct, which is indicative of indicator reliability. So how much variance in each of your indicator is explained by your latent construct. And this shows you the indicator reliability. Now to compute an indicator's explained variance, we need to square off the loadings that we saw in earlier videos as well. And that loading is actually the bivariate correlation between the indicator and the construct. As such, the indicator reliability indicates communality of an indicator. So indicator loadings above 0.708 are recommended since they indicate that the construct explains more than 50% of the indicator's variance, thus providing acceptable indicator reliability. In summary, if your indicator loading is 0.708 or over 0.708, this would mean that 50% of the indicator's variance is explained by the construct. And this will show indicator reliability or acceptable indicator reliability. Moving on. So how do we improve indicator reliability if it is less than the threshold value? Now, researchers frequently obtain weaker indicator loading, that is less than 0.708, for their measurement models in social sciences studies, especially when newly developed scales are used. Rather than automatically eliminating indicators when their loading is less than 0.70, researchers should carefully examine the effects of indicator removal on their reliability and validity measures. And this is what we have discussed in earlier sessions as well. Generally, indicators with loadings between 0.40 to 0.708 shall be considered for removal only when deleting the indicator leads to an increase in internal consistency reliability or convergent validity, and this is to be discussed in future sections as well. Now, another consideration in the decision whether to delete an item or not is the content validity. Now, if it is affecting the content validity, then you have to be very cautious in removing the item. As a consequence, indicators with lower loadings are sometimes retained. Indicators with very low loadings, that is less than 0.40, should, however, always be eliminated from the measurement model. Now, how do we assess indicator reliability? We need to estimate the relationship between reflectively measured constructs and their indicators. All indicators' loadings of the reflectively measured constructs are well above the threshold value or shall be above the threshold value 0.708, which suggests sufficient level of indicator reliability. Variance is explained by taking square of the loadings, indicating indicator reliability if it's over 0.50. Now let's have a look at our model. Here, let's run it. Now what's the error? An unexpected error occurred and has been reported. It will be fixed in one of the next smart PLS releases. Okay, now let's calculate PLS algorithm. Now since I've got the earlier version for the sake of testing and making videos, so that's the reason there was an error. But anyways, coming back, all over 0.708, over 0.708, no issue of indicator reliability. Moving on. Next, we assess indicator consistency reliability. Now, previously we assessed the indicator reliability. In this part of the video, we are going to assess the internal consistency reliability for the construct. Now, the second step in reflective measurement model assessment involves examining internal consistency reliability. Now, one of the primary measures in PLS-SCM is composite reliability rho C. Higher values indicate higher level of reliability. Values over 0.70 are normally considered reliable. Now, reliability values between 0.60 and 0.70 are considered acceptable in exploratory research, whereas values between 0.70 and 0.90 range from satisfactory to good. Now, values above 0.90 and definitely above 0.95 are problematic, since they indicate that the indicators are redundant, thereby reducing construct validity. Reliability values of 0.95 and above suggest that the possibility of undesirable response patterns, that is straight lining, thereby triggering inflated correlations among the error terms of the indicators. Now, Cronbach Alpha is another measure of internal consistency reliability, which assumes the same thresholds as that of composite reliability rho C. Now, a major limitation of Cronbach Alpha, however, is that it assumes all indicator loadings are the same in the population. Now, this is also referred to as tau equivalence. The violation of this assumption manifests itself in lower reliability values than those of composite reliability rho C. Now, while Cronbach Alpha is conservative, the composite reliability rho C is liberal, and the construct's true reliability is something in between the two, and that is referred to as rho A, reliability coefficient. The reliability coefficient rho A usually is between Cronbach Alpha and composite reliability, and is therefore considered an acceptable compromise between the two measures. Now, how do you get the reliability? Let's go to Smart PLS 4. So we go to our report, or you can get it here as well if you just hover your mouse around. Cronbach Alpha 0.876, reliability or composite reliability 0.906, rho A 0.880, which is in between the two. Again, for OP, it is reliable as well. Now, how do you get it in the report? If you come here, go to quality criteria, construct reliability and validity, and just click overview. Here you've got it. You can copy it here. Just select, right click, copy. And now you can paste it into Excel and then import it into the Word document. If you paste it directly into the Word document, you might have some issues. Let me try it, because we did have issues with Smart PLS 3 because it used to paste it in text form. Let's paste it here, still in text form, not in the table format, so better put it in Excel and then import it here. Now here are the same results from Smart PLS, and if you look, this is reliable. Now rho A is between these two. 0.876 is less than rho A, and this here is greater than rho A. 0.8912 is less than rho A, and 0.913 is less than 0.935, or the other way around, composite reliability is greater than rho A. So this value falls in between these two values. Now, to know more about reliability, you can refer to this text. Thank you very much.